All right, we are now moving on to floods. um, this I can see. All right. Flood is a condition in which the stream stage is above channel bank height. So the channel bank is pretty much like the banks of the river that you would think of. And so stage is the height of the river. And so once the water is above the banks, then it floods, as shown here, where it's all within its floodplain. Um, and that's a flood. When water that does not infiltrate into the ground, it becomes surface runoff. So it will soak into the soil or the bedrock as much as it can, but once the soil is saturated, then it just flows off the top. Um, and then so the surface water will overflow the stream. The groundwater will eventually end up in the stream too, but it's a much slower path, so that doesn't usually cause the flooding. It's usually the runoff that does. The runoff is what we call the stuff that doesn't soak into the ground. Um, Flooding can be frequent or infrequent. Obviously, I think we know that. Um, and our understanding of frequency is based on past stream behavior. And we have charts and things, we graph them. Um, so factors are the quantity of water and the rate at which it enters the stream. So if you have an excessive intense rainfall or snow melt from mountains or severe storms, or like, unusually wet weather seasons, these atmospheric rivers they keep talking about. The geology of the drainage basin also influences how much runoff occurs. It just depends, the soil and the rock can be porous and permeable, or it cannot. The topography, if it's steep or if it's flat, is going to affect, how quickly the water is getting to the stream. As a review, porous are the little holes in the rock, and permeability is how well those holes are connected, allowing fluids to flow through the rock. Vegetation plants can provide physical barriers to surface runoff. The roots can, suck up some of the water themselves. They can help with soil's permeability because their roots will help make little paths in the soil. Um, and the dead plant material is effective at preventing soil erosion. I mean, even the roots are effective at preventing soil erosion. And then the season, frozen ground can cause increased runoff, well, because it's ice is not very permeable. And rapid snow melt in spring can produce flooding because everything that fell didn't get into the streams when it fell. It's all the whole winter's worth, especially in these places like Colorado or up north where it doesn't really thaw out after each snowstorm. It just piles up. And then in the spring, all those, 3 or 4 or 5 months of precipitation just melts at once, and then that'll cause a flood as well. Um, Stream or flood characteristics. We have velocity, height, and discharge. They all increase. Stage, like I said, is the height or elevation of the stream. Flood stage means that the stage exceeded the bank height, and crust is that maximum stage, or so the maximum height reached during a flood event. There are different types of floods. There are upstream floods. These are very, very dangerous. This is more of your flash flooding. This here would be like an upstream flood. And it's because upstream, it's the drainage basin is much smaller, and you're more likely in an area where the streams are wanting to down cut, not that wide valley situation. So if you get too much rain in like a narrow area, in a little narrow valley, water doesn't really have the chance to spread out. It has to go up. Here's an example of a slot canyon in like Arizona. Um, and so you can see if it just started just dumping rain, where's it going to go? It really can't go anywhere. It's going to come up these walls and it's going to flow down hill, whichever direction that is, just crazy fast. So it's actually the monsoons in these canyons here in that western deserts are very, very dangerous. Downstream flood They're the longer lasting floods that usually cover more area, but they're also slower to rise. So they don't really have that scary, like, oh my goodness, like, I got to get out of here now kind of thing. It's like, shoot, I got to get out of here like by tomorrow. Let me like get my nice belongings out of my house kind of situation. And that's because you're more downstream where things have flattened out. You're more in that meandering situation. So the water does have the chance to spread out as well as spread up. So it doesn't spread up, which probably isn't even a term, but it doesn't rise. That's the word. It doesn't rise as quickly. We talked about flash floods. Okay. Here's a hydrograph, which is a graph of discharge against time. It records the fluctuations in discharge, and it just helps the scientists monitor stream behavior. Floods are always high discharge events on the graph. They're the shapes of the peaks indicate relative location of measurement within drainage basin. So like here, this one, this is what I was talking about. So this is an upstream. So you can see like really, really quickly, it doesn't last very long, but it gets super high, super fast, and then it just does kind of go away. So down here in the larger drainage basin, like lower on that profile of the river, it doesn't rise as high, but it lasts a lot longer. But as it's rising, you kind of do have time to get out of its way and grab a few belongings, and then you're going to be out for a while of your home before you can come back in. But it's just not as quickly or not as quick or as scary. Gosh, I had something else I wanted to say, and I can't remember what it was. Flood frequency. This is a recurrence interval, the average length of time between floods of a given size of a particular stream. So this is the 100-year flood. Means statistically speaking, it's going to happen every 100 years, which is the same as a 1% flood. So if the size of that, so the 100-year flood would be something that has a discharge of about 1,000 cubic feet per second. If you want to know how often it might rise or the discharge might be 400 cubic feet per second, then on here, that's between 2 and 3. Maybe if it's so that's a 2-year flood, which means every year there's a 50% chance that could happen. Every year there's a 1% chance the 100-year flood could happen. And so they graph out the recurrence interval and the frequency, and then they figure this out. Just reading the history data or the historical data on the chart. We are seeing a trend, especially in the southeast, that we're getting a lot more floods. And so these 100-year floods are actually kind of becoming more frequent. And this graph is starting to shift. So what was a 100-year flood would now be plotting maybe at a 50-year flood. And the more, obviously, it takes time to record this data. But in like another 10 years, we'll have this data with all these floods we've been having, and our recurrence interval is going to change. Flood frequency curve is a graph. That's what we've been looking at, which has the recurrence interval. Okay, I don't think I need to say anything else on this then. And that is it. Next, we will be moving into floods and people.